So we're starting mod 7, and mod 7 just builds off that same idea that warm-up was based on. The only difference is they don't give us our first factor. So we need to figure out where that first factor is. Okay, so what's wrong? Okay. So we're going to start out with relating zeros and coefficients of polynomial functions. So this first part says the zeros of the polynomial function and the coefficients of the function are related. So let's look at that f of x. F of x is equal to x plus 2, x minus 1 times x plus 3. So what are my zeros going to be for this polynomial? So now let's put this function in standard form. How do I write a polynomial that's factored into standard form? All I do is I take my factors and I multiply them together. So how do I multiply this? We just start with our first two. So we start FOILing, and you would get x squared minus 1x minus 2 plus 2x, right? Okay. So you get x squared plus 1x minus 2, and then you multiply and drag that piece down. And then you just do the same thing and you FOIL. So you get x cubed plus 3x squared plus 1x squared plus 3x minus 2x minus 6. And so you end up getting x cubed plus 4x minus 1x minus 6. Yes, thank you. Okay, so that's my standard form. And when a polynomial is in standard form, my degree goes from my greatest degree to my least degree down to my constant term. And what is my constant term? So that is my constant. And yeah, what is my, of that polynomial, what is my leading coefficient? 1. Yep, so the number in front of the term with the greatest degree is your leading coefficient. Now somebody see if they can answer this question. How are the zeros of my function related to the standard form? So here's my standard form, and here's my zeros. Exactly. So Trey said that my zeros multiply together. So my zeros are -2 times 1 times -3. Those are going to multiply to equal my constant term. So I'll write this in a better way. Okay? So we can say each of the zeros of the function.
Wait, how is that -6? It's positive 3?
No, because those are the opposites.
My zeros. How are the zeros related? So good call.
Yeah, but
So what are my zeros of my function? So not that, so my zeros are 2. I think I must have written this incorrectly. So 2, -1, So it's negative 2, 1, and 3. Huh.
But
Is that a minus 6?
Plus,
Yeah.
no, because it'd
No,
be
it isn't.
negative 2 times 3.
Mm-hmm. Negative 2, 1.
Yeah, that's what computer did.
Okay.
So I understand that would be positive. Your times your zero.
So, yeah. I don't know. So why, so the zeros of the function are negative 2, 1, and negative 3. X are equal to those. And that is a positive 6. And we have our constant term of a negative 6. I think there's just a little mistake somewhere, but I don't catch it. Correct.
It's still 2 times negative 1 is negative
Yeah,
2 times 3 is 6.
times the negative 3.
there's something wrong in our,
I think that there's just something wrong with it. Doesn't. The fact, okay. That's what I think too. So we're just looking at the fact that they are factors of 6, okay? Can I have those of you who are talking please sit forward? Okay, so each of the zeros of the function are a factor. So this is a good thing for your notes. Of the constant term in standard form. Okay? Now consider the polynomial g of x is equal to 2x plus 3 times 4x minus 5 times 6x minus 1. So we're going to identify the zeros of this function. So does anybody remember how to do that? So you go negative 3 halves, 5 fourths, and 1 sixth. Okay? So we're going to do the same thing. So multiply the factors. And just to save time, I'm just going to, I already had done this in my notes, so I'm just going to tell you what this is. So we would end up with 40, so if we did the same method that we did before, 48x cubed plus 4x squared minus 92x plus 15. Okay? So if we just FOILed those out, how are the zeros of this function up here related to the standard form of our function? So pay attention to our leading coefficient and our constant term. So let's check out, yeah. So let's look at the numerator of our zeros. So our numerator is negative 3, 5, and 1. Those are all factors of 15, right? 3, 5, and 2, 4, and 6, those are all factors of 48, our leading coefficient. So can somebody tell me how these zeros are related? So each of the numerators of the zeros of the function in standard form. What? Of the constant are factors, are factors of the constant term. And how would I talk about the leading coefficient? Each of the denominators is a factor of the leading coefficient. (48). Okay? So let's start on example 1. Oops. So example 1 says, find the rational zeros of the polynomial function, then write the function as a product of factors. So the first thing that we're doing is finding our possible rational zeros. So there's 3 steps to doing these problems. Okay? The first step is finding all possible rational zeros. Okay? And we're just going to use what we learned about the numerator and the denominator and apply that here. So I'm going to take my constant term, -20, and make that my, or you could use +20 since we found out sign doesn't necessarily matter because it's just factors. And you'll see why in a second. And then what is my denominator going to be? My leading coefficient, yep. So now, using that, I'm going to find all of my factors of 20. And I'm going to use the sign plus or minus to indicate that I could have positive or negative numbers. Looks like a hashtag. Plus or minus. So what are my factors of 20? I've got 4 and 5. I've got 1. I've got 2. So I'm just writing these in order, right? 10 and 20. So those are all my factors. Okay? So when you're doing these problems, you have to show me that you know all of your possible rational zeros. And they're just possible factors. And then what about 1? It's just 1. This is my only factor, 1. So I can have plus or minus 1, plus or minus 2, plus or minus 4, etc., etc. Okay? The second step is using technology to test, well, which ones are our zeros. So we can use our calculators and plug in our function.
120.
Do you guys know why this would be opening? Oh, okay.
There you go.
Okay, so does somebody want to try plugging my polynomial in while this is loading? There it is, it's hiding. So I have, can I make that bigger?
I think so.
Isn't, I wonder if there's a way that I can pull that, okay, there we go. All right. I know. So I have, gonna go into my graph. Yeah. Oh, there we go. Okay. It's very slow on the tablet. Okay, can somebody read me what the polynomial is?
X cubed plus x squared minus 19x minus 20. For all that.
Plus 2x squared.
Yes.
Plus 2. And then plus
Minus 19x.
minus 19x.
Minus.
Okay. So, what does that look like? Where does it cross the x-axis?
-5, -1.
Okay. So I can look at this and I can see it crosses at -5, -1, and 4. So this is basically, this part is just telling me which of these options, these are possible rational zeros. The calculator tells me these are my rational zeros. So out of these possibles, I can see, okay, well, it was -5, it's -1 and 4. And this is saving you a step for this next part. So now we're just going to do what we did on the warm-up, because we know we can use, so this is x is equal to those, -5, -1, and 4. So let's start using our synthetic division. So now that we are given a factor, let's use -1 and divide our polynomial by that. So we have 1. Okay, so when it crosses the x-axis, so whatever x is equal to goes in the box, and where it crosses the x-axis is where x is equal to. Good question. Okay, so what is my synthetic division going to look like here? So I'm going to have 1, -1, 1, -1, and then plus 20. So guess what? I got a remainder of 0. So now this is the next step. So this is the new part. We can just keep going with this and keep factoring. So this is like our new method of factoring. That's kind of a cool trick that you can use. So now I can just, so last time I used -1. Now let's use 4 and just do synthetic division again on that part. So all I'm doing is just doing this again. So 1, 4, 5, 20. So I get a remainder of 0. And what am I left over with? Yep, so I'm left over with x plus 5. And I just showed, essentially, I just proved that all of these factors, where it crosses the x-axis, I just proved that using synthetic division. Because remember that little thing before, if I got a remainder of 0, it was a factor? So I got a remainder of 0 when I used -1, so that's a factor. I got a remainder of 0, so I showed that this is a factor. So how would I write all my 3 factors out? This is the part you need to be careful on. X minus 4, x plus 1. Okay? So that's how you show your factors. And on the homework, you're just going to be doing that same thing. So I'll hand out the worksheet. And it's really not too long, just a couple problems. Due on Tuesday.
I cannot figure this out.
Have a great weekend, guys.
Okay, what are you trying to figure out?
Ansel Brady, please come to the office. Ansel Brady. Dawson, please come to the office. Thank you.
Good luck to the basketball
Come
players.
look at it, Dawson, it's so hard.
Beat Livingston.
It's so hard. Just come watch it.
What time do you play?
4:30.
Today?
Actually, in Russ, but
This place.
I played at 4:30.
so there
Seven.
could be 6-0 to 6.
Dawson, who's your coach then? Are you JV or varsity? Okay.
Got the 2 stars right there.
Cool. I do want to watch you guys play sometime.
So there has to be 6-0.
If I could convince one of my friends to come with me, I would go.
6-0, 6 ones in each column. There can only be 2 numbers alike next to each other. Yeah, we made boxes and we decided that